Hello, welcome to another episode of Xa Talk Show. Today we are going to code Advent of Code 2022 problem day 7. We're gonna continue. We didn't finish last time in Wolfram language. Okay, and today we might start to talk about something else. Depends on whoever is here. If comment and I'll maybe talk about that. Otherwise, we're gonna continue. Wolfram language probably because I asked, and there are two people who wanted to see Wolfram language, Camille and random icon. Okay, so let's continue code Wolfram language. There's a lot to do. Okay, so nobody's watching. So let's begin. Okay, so let's begin code Wolfram language. So today's talk show, okay, show it, and let's go up. So day 7, we did day 7. Let's see day 7. Okay, so let's go to it. Let's put the link here. Day 7. Okay, copy and go to Xa's talk show today. Hello, a Googler. Okay, so here is day 7. We did 2 times, and we still didn't finish last time. Day 7 is one of the harder problem. Okay, so a Googler says, I vote for graph theory, network science. I'm interested in this topic. Graph theory, network science. Okay, graph theory is very interesting, and especially for you programmers and for you for you industrial programmers like web dev or whatever, or Linux, so for you people, graph theory is one of the mathematics topic that you might be interested and you might be good at. Graph theory. So graph theory is part of discrete math. Okay, I don't think I'm going to do a topic on that because I don't, I learned graph theory long ago, so I'm just gonna ramble something about it. Okay, so here is this is not really graph theory, but this is all possible ways to visit n nodes. Okay, this is a problem I did in like 20 years ago in Wolfram language, of course. All the possible ways to visit n nodes. So this one is not graph theory, okay? But however, I mean, it's an interesting programming problem, since we are doing advent of code. So the problem is given n nodes. Let's say n is 1, 2, 3, 4, 5, 6. So you have all these possible ways. So there are two problems. One problem is find the function. The function takes n and output another number. That is all the possible ways to traverse these n nodes. Okay, is there a specification? Yeah, to connect all these nodes. That is the problem. Doesn't matter they cross or not. Okay, and so write a function that computes how many possible ways to connect n dots. And this problem, there are two subparts. One is if you consider symmetry. For example, let's go simpler. For example, if the node is 4, then there are these 3 ways. But however, you can look at these two, they are essentially the same. You just rotate it. So there's a symmetry reduction. So if you count distinct ways, you can start to think of this as a graph, okay? So distinct, this graph, or these are specific type of graph. They are called a loop. Okay, a graph is a loop when there is one and only one path that connects them all, something like that. A loop, there's a definition. So graph theory, you can look up Wikipedia. I learned a lot of things from Wikipedia. You can learn, especially, so Wikipedia is a great resource for mathematics and computing, but not for politics. Anything politics, related to any news sensitive, China, USA, Russia, any news, any news, sensitive topics, religion, or vote, all those are corrupted on Wikipedia. So, but however, for technical topics, programming, math, Wikipedia is fantastic. Okay, it's basically the best resource. So you can learn. Traditionally you can learn this, by going to a university, take a course. But today, if you are the autodidactic type of person like me, you learn by yourself. You can learn essentially the whole thing. You can, in fact, be a master of graph theory just by reading Wikipedia. Keep reading it and understand it. Read it for several months, for half a year. You'll be expert of graph theory. Okay. But otherwise, you usually go to university, take a course, and they don't teach this much because graph theory, they are part of discrete mathematics. Okay, so to a mathematician, the traditional mathematician, this is not considered. I mean, this is part of math, but they are not the mainstream mathematics. So what is mainstream mathematics? They are topology, analysis, complex analysis, algebra, differential geometry, algebraic geometry, very, very advanced, very high level. You have to spend 4 years to even have a basic understanding what they are. Manifold, varieties, algebraic varieties, and today, and in the past 30 years, you have topos and lots of complex ideas. These ideas you don't even understand until you spend 4 years studying mathematics, be a math major in university. So that's a professional mathematics. Typically, they focus on those things. But graph theory and discrete mathematics, okay, this and recreational math, these are also very deep. Okay, these are also very deep. This is not trivial. And combinatorics, graph theory, logic, discrete mathematics, and finite mathematics, this kind of thing are very easy to understand because you spend 10 minutes, you'll understand what's a graph, and you'll immediately know some problems that's not solved. Okay, that is unsolved. If you can solve it, you'll have $1 million right away. You can understand it in 1 hour. You can understand all the questions about graph theory, enumeration, and so on. So let me say again: traditional mathematics that are spread by professional mathematicians, they are typically topology, complex analysis, and analytic geometry. Analytic number theory. And fractals, chaos theory, dynamical systems. Basically, they almost all of them involving calculus. Okay, and algebra. Abstract algebra, group theory, field. Those are traditional mathematics, algebraic geometry, and so on, differential geometry. But on the other side, you have discrete mathematics and finite mathematics, where typically you don't have infinity. You deal with discrete. Discrete means not continuous. Okay, so you either discrete or it doesn't involve infinity. Okay, so this finite math, graph theory, recreational mathematics, that's also seems silly for children, but all these things, and game theory. Okay, so this is, and also logic, this is a bit not mainstream of the kind of the professional mathematics. Okay, however, they are very deep. Okay, they are not trivial. So graph theory is one part of it, and I'm giving a very, very rough description, that not necessarily true. I mean, that's not necessarily you can't really say that professional mathematicians doesn't do graph theory. A lot do. So anyway, graph theory is very interesting. Okay, and what I want to say about it, yeah, I cannot give you a course because it's quite involved. But yeah, I wanted to show you some of the book I recommend. Okay, so let's see. Graph. Okay. Okay, so it's not there. So you search for book, math books, for math books. Okay, so there it is, one of them. And free math books, that's another. And math and geometry books. So I have some of these books. I'm a math fanatics, especially when I'm in the 1990s. I wanted to be a mathematician. So I read all these books. Well, most of them I read at least half of it, or something. So graph theory, the book I learned graph theory is this one. Fantastic. Okay, graph theory book. Okay, and yeah, I recommended on my live stream a few times. So someone also bought it. Who is this guy? Photo by Rene. Okay, Rene. He haven't been in our forum for a while. Anyway, so this book is great. It's pretty cheap. That I learned graph theory from. Okay. And this book is also great. I learned group theory from in the 1990s. So these two. Then let me show you some other math books. Okay. Many of these, you can read my website. I highly recommend if you want to study complex analysis. This one is a great book, Visual Complex Analysis, and this is another super interesting. This book I'm interested in the most, tiling and patterns. Okay, you study tilings and patterns. It seems silly, but this very deep. And this book is almost like the reference. There's no other. Again, like I said before, this kind of mathematics topic, so this belong to, you might say, this is not mainstream. You will not find a course that teaches this in university. Well, except this professor, Guanben, he's one of the top professor on this topic in Sherpa. Guanben passed away. I realized Guanben passed away a few years ago, 5 years ago or something, 3 years ago, recently. I don't know about the other. But anyway, so back in 1990s, I was studying this book, and actually I wrote to the professor. I have some questions, I wanted some reference, in his, and he sent me a bunch of his work and references, reprint. He printed out, he sent it to me, mail, postal mail to me. I still have it stacked somewhere, but I failed to be, I failed to continue to do mathematics. But anyway, so this is a fantastic book. Okay, it's out of print, but Dover printed again with this idiotic cover. Dover is a publication that they reprint books, books that has gone out of print or people has forgotten. Typically, Dover reprints them, and they they usually they have idiotic illustration like this one, like because this is because this one, first of all, it's beautiful, just aesthetically. If you don't know anything about math, you just look at this one is beautiful. Okay. These are fucking idiotic for children, okay? But besides aesthetics, this tiling actually illustrates a particular specific example that's rare. It's like one of those counter example. Is this possible? Nobody knows for many years until someone made it. Then it's a big discovery in math. Then we know, oh, this is an example or counter example. It's possible. So this besides being beautiful, it has deep meaning. This illustration. But Dover, the idiotic Dover, changed it to children's illustration book. A fucking idiot. Anyway, so I recommend this book. Okay, some books I recommend. So that one. And of course, you guys might know Stefan Wolfram, since I'm doing Wolfram language all the time. So Stefan Wolfram, I read this book basically 3 times. In particular, chapter 1 to 6. During the 2000s. So this is another topic that many of you programmers might be interested. Again, cellular automata. That's the topic of this book. It's not the mainstream mathematics. Okay. And Stefan Wolfram doesn't even consider it math. He has his own vision. So, but anyway, this book is controversial and it's very tedious to read because every sentence, every page, he'll say, Stefan Wolfram will implicate, I'm the greatest scientist. And repeats every page. It will repeat, oh, this pattern creates randomness. Very tedious. But however, it has solid content. This book is about 2,000 pages, something like that. Okay, 2,000, 2,000 pages, like this thick, heavy. So this book I can also recommend. Endless topics. As a programmer or as a young people, you have today endless topic to learn. So and group theory, okay, also interesting. So this book, so I recommend that. So okay, I recommend those books. Meanwhile, and also today you can learn a lot of these, almost all of these, on Wikipedia. Like I said, you can spend years. I read encyclopedia for like an hour a day since 1990s. So before Wikipedia, I go to the library. There's Encyclopedia Britannica. Then there's American's Gorillas Encyclopedia, and there are a few others. I check them out. I'm a fanatic of reading encyclopedias on all sort of topics. So, but today, truly, you can just spend years on all the math on Wikipedia. You will learn. The issue is that are you willing to or not? Do you want to spend the time? So like I said to many of you, young people, stop, hanging around 4chan, hanging around Reddit, hanging around Hacker News, posting shit posting memes, and being a non. Stop that. There's so much to learn. If you want to do something useful or even to stay relevant, study, and you can be a great programmer or mathematician or related field, but also that's what I am. I'm that type of people. I'm a nerd. But if you are not a nerd, well, most likely you are not gonna watch my video. But of course, there are many other fields you can go to. Just don't waste time. Don't do stupid things. Do something useful to yourself, make yourself happy, and have a good life and have a good career. Okay, so graph theory, very interesting. Okay, so but I cannot teach you. I'm not qualified to do so. So besides those few books, finite math and recreational and also discrete math, there are also books like, for example, on this page, I have collected many of the free textbooks that's open source. Okay, that's online and open source. I've collected them on my website. So if you want introduction to number theory, I collected. I looked them over. So these are resources. These are books that I trust. Okay, so if you trust me, you can follow if you want to learn. So this one is very basic beginner number theory, and this guy Edwin Clark, he's a critic of Stefan Wolfram's book. Okay, he's a major critic of Stefan Wolfram. Anyway, so but he has written, elementary number theory, so it's good. And the introduction to number theory and algebra. So this one I actually don't know much about, but I suppose it's okay. So number theory, there's a probability, all from the, these are actual textbooks. So you will spend several months to actually read them, several months. They are, 400 pages, 500 pages. And then you have many calculus textbooks. So I've collected a few. They are all open source, okay? Just like today, the USA, for example, at least USA has become so corrupted by all the high-level powers, Like you go to college, it's like tens of $1,000s a year. But that's not all. One textbook, you go to college, you buy one calculus textbook. They are $100, $200. Jesus, that's an incredible scam. To an impossible to believe degree. Even back in the 1990s, when I was going to college, I bought calculus books. Those are like $50 and very expensive. But today it's like few $100s. But the thing is, calculus, the topic of calculus, has not actually, you can say for sure, the topic of calculus for beginners, for undergraduate, has not changed. Zero change. Okay, so you can actually use a book from the 1990s. Makes no difference, absolutely. Okay, and so you can go to used book. People throw them out. Tons of used book. But today you have to buy one because the professor says, and it costs $300, $200. That's incredible scam. Okay, incredible scam. Because and then some of the book. At one time I looked into why. Okay, so at one time I looked into why is today's textbooks so expensive. I love textbooks because they are no nonsense. If you want to study physics, chemistry, mechanical engineering or electronics engineering or calculus or many of the topics, linear algebra, analysis, textbooks. I love textbooks because they don't talk shit. They just, you learn this, your master. Each one of these takes humanity several hundred years to create, because these are basically the essence. For example, calculus, took Newton, Leibniz, all their life to actually try to make them into like a coherent thing. Then many mathematicians afterwards to iron out the the flaws, to make proofs, to make the differential logically sound, So all textbooks they are the essence of human academic learning. Okay, so that's progress. You can learn them. You can learn the entire subject. Just spending several months, on the book. So I love textbooks, chemistry or whatever. So I looked into, so why is textbook so expensive? Because a huge amount of scam by these elite people. For example, let me show you. So go to search. So Xali search. Oh, we have a lot common. A lot of people. Happy New Year. Oh, only 4. Shit. So you can see, I looked into, 5 years ago, why is calculus books so expensive? What the fuck? $250, $230. It should be free. It's the same thing from 1990s. There's no change on the subject of calculus. Okay. So it turns out it's just scam. Okay, there are reasons. Of course, because USA is, they focus on capitalism and capitalism, free market is not bad. What's bad is that there's a lot of corruption. So they prevent, for example, they prevent you from using used textbook, because if you use used one, nobody will buy it. So they tell the professor in some way to force you to buy certain books, and lots of other reasons. So that's why textbooks become so expensive. A huge scam. Okay, so anyway, that's about textbooks, and that's about some of these books I can recommend: calculus and linear algebra. And then gets harder, real analysis. That's when you finish calculus, you have real analysis. Then you have complex analysis. I love this topic, complex analysis. Then differential geometry. And here is Richard Palais, my mentor, who taught me so many things in mathematics. Then there's then you get into topology, and logic is kind of separate. Logic is not mainstream mathematics, okay, but still it's a deep, very deep topic. And this homotopy type theory, I hope to learn before I die. I hope to have some good understanding of it before I die. Homotopy type theory, which is a new foundation of mathematics that is suitable for doing it by computer. There's a big question, because traditional math and computing, there's a certain incompatibility. Until about 10 years ago, there is this mathematician who came from traditional math background, this guy, okay? So I have some notes. This guy, Vladimir Voldovsky, a Russian, I think. He died 3 years ago, pretty sad. He died 3 years ago, pretty young. So he basically he created this new foundation of mathematics, okay, which he calls homotopy type theory, or univalent foundation of math. Okay, this is a very interesting topic, and probably interesting to you guys, because I know lots of you are interested in Haskell, and today we are more and more focused, interested in provable programs, correctness, Haskell type theory. So anyway, so this I recommend, okay? I hope to learn myself. Then there's category theory. Category theory, I don't give a shit about it. I don't care, but actually I do have a page about it. I'm thinking of deleting it, because I haven't read this book. I don't like category theory, okay? Category theory is, it's valid, for sure, it's valid. I'm not really qualified to say, to give you my opinion about category theory, okay? I'm not qualified, because I don't really understand the subject. But I can tell you, all the Haskell people talking about it, they know less than me, okay? And category theory becomes, popular among programmers because of Haskell, because these idiots, they don't know nothing. These people, they're talking about Haskell all day and all night. They tell you Haskell this way or that way because category, okay? These people don't know any of these basic mathematics, okay? That's the Haskell people, the fucking idiots, okay? So but category theory is indeed, of course, it's a valid part of mathematics. And it's also related to foundation of math, okay? But I wouldn't, you'll have to learn it eventually if you are interested in homotopy type theory, okay? So category theory, you can base it on homotopy type theory, okay? So, but anyway, so the big reason I don't like category theory is because it's all the fad. it's corrupted by these Haskell people, idiots. Okay, they don't know anything about any of these topology, differential geometry. You ask them what's a group, they don't know. They don't know a thing. But they're gonna tell you a category. This is a category of something. Yeah, fucking idiots. Okay, category theory. Okay, that's some of my introduction to some of the math stuff. Okay, so I talked for 30 minutes. Let's look at what comments we have. Do you have any advice on how to read academic papers? As I mentioned, I'm reading about graph drawing layout algorithms, and a lot of recent development only described in papers. No, well, if you are doing that, it looks like you are already fairly advanced. You don't need my advice. How to read papers? Like, how to read papers? Well, focus, pay attention, try to understand what it says. That's what you want me to say about it. Your video is very helpful. Thank you. Russian friend agreed. Hi, Xa. Any book you would recommend that runs through rigorous math proofs with all the involved steps and examples? Like, well, all these books I recommended, all these books I just talked about, they are kind of like that. Essentially, all mathematics is like that, okay? Proof for even and odd numbers. What? Yeah, so, that's from your question, I can tell you don't have basic math. So, you need to go through calculus, and stuff. Mind test. Okay, I don't know what is mind test. Jeff Money says they sometimes make you pay for online homework now so that you can buy used books. Yeah. Pay for online homework. Rodolph says, agreed on textbooks, the best bang of the buck, open source textbooks. Yeah. What do you see as more low-level computation? What do you see as more level, computation or math? In other words, do you see math as an abstract build on top of computing or the other way around? That question, that depends on your point of view. That's not, because first of all, you are trying to presume there's some kind of hierarchy. Like, let me say, let me just go freely, free thoughts on that thing. So you are presuming that there's some kind of hierarchy, or is math better, more fundamental than computing, or is computing more fundamental than mathematics? Yeah, but what do you mean by math? What is computing? That you have to define it. What doesn't seem to make sense from the that kind of question. Okay, so I think let's begin to code Wolfram language. I want to start to code. So let's close and let's put some of the links to my talk show so we have a record. Okay, the pink window shows all my command calls. Okay, why textbooks are expensive? Close that. Notes on a new kind of science. Okay, close that. Okay, math textbooks. Close that. Fun math books. Okay. Oh yeah, I forgot to. There are some fun math books. I should mention a few. So these are easy going. Okay, so there's also a book on knots, which I haven't read. I don't know if it's good. These are old books from 1990s. So knot theory is also a great, very interesting topic. Okay, and then there's this Flatland, which I have a copy. It's out of copyright, so I have it online. This is a fantastic introduction to the idea of dimensions, For example, when people say higher dimension, fourth dimension, fifth dimension, what does it mean? So this book is a fiction. This is, you classify this book as a science fiction, and it solidly introduces you to understand the concept of dimension. Okay, so then after reading this book, you'll know what it means. But this book is not just about dimension. This book is very popular. Okay, there are several movies out of it. You probably already know if you are into math, but if you haven't heard, let me give you an introduction. This book, Romance of Many Dimensions, it's very short. Okay, you can finish reading it in 3 hours. Okay, it's very short. It's a science fiction technically, and there are 2 parts. Okay, the second part of the book introduces you, makes you understand what is a higher dimension, fourth dimension, fifth dimension. It makes you understand it without any math. There's no formula in this book. It's a science fiction, okay? But you'll understand dimension in mathematics. By the way, it's not time. Because today, if you haven't studied math, you go to YouTube, you'll see, oh, dimension, oh, magic, oh, ghost, oh, Einstein, time and time travel, fucking idiots. Okay, those are just brainwashing. Those are almost all of it. Any YouTube video, if they talk about dimension, okay, 90%, more than 95%, more than 95%, 99% of them is bullshit. They are you will be misled. Okay, 99% of YouTube, any one of them, if they talk about dimension, okay, you're being misled. Don't read them. Okay, don't watch them. Except I can recommend, since we are on topic of math, I can recommend there's one YouTube called Blue Brown something. Okay, that I highly recommend. That's real math. Okay, 3 blue, 1 brown. Okay, so if you want to learn math, I can recommend you can actually just watch every single one of his video. I highly recommend. This is a real math. Okay, lots of math on YouTube. They are all bullshit. They mislead you. I mean, here's a question: do you really want to learn math? Math as the real mathematician's math. The math that gets you go to space, build rockets. Those real. Okay, then you can. Then this 3 blue 1 brown is a good channel. You pick some topic that's easy. Okay, there's some topic is more advanced. And this guy is also a programmer, so it's suitable for us. A lot of us also are programmers, so you can neural networks, machine learning. So this is a good channel. Okay, he teaches you real math. Meanwhile, let me say a few. This number file, it's idiotic. Okay, number file. Then there's also programming file or something. I don't recommend. Okay. Yeah, of course, and there are a lot of professors. So many. Okay, if you really want to learn also the homotopy type theory. That guy also has given lectures, and also a lot of professors on cutting edge of these highly advanced, topology or, or even category theory. They talk on YouTube, but usually it's very, very boring. You have no idea what they're talking about, But anyway, so the 3 blue 1 brown is a good resource. Okay. I recommend this and nothing else because vast majority, 90%, 99% of the YouTubes talking about math, they are just pure bullshit. They mislead you to bad thinking. Okay. Okay, so that I can recommend. So let's see what else. So yeah, this book is great. Okay. flatland. Oh yeah, so the part 2 teaches you about dimensions of math. Part 1 is entirely different. Part 1 is a mock history of the dark side of humanity. Okay, so go read it. Okay, on my website you can just search for. It's on ksali.org. Okay, just search for. You go to ksali.org and go to Wordy English, then go to Literature Classics, then you'll find it. Flatland, A Romance of Many Dimensions. This book I read 4 times, okay, through different years. In 1990s, in year 2000, then last time I read is maybe 5 years ago. I read it at cover to cover at least 4 times, and I also made some annotations. So like if you go through, you'll see some of my annotations. For example, those are the annotations I made myself. Okay, so check this out. Flatland, A Romance of Many Dimensions. Okay, then what else? Let's see. Let's go back. What is this? Okay, Flatland. Yeah. So let's. So this page, copy it. Link. Fun math books. Oh, it's already there. Okay, go back. Close graph theory. Okay, very interesting. I don't know anything about it. Okay, let's go back. We already talked about 40 minutes. Now let's do. Okay, let's code Wolfram language. Let's solve day 5. So day 5 is the problem. Here's the day 5. So it gives you the input like that. It's a text, okay? It's a text file of input like that. Basically, it's like the Unix, Linux directory navigation. So you type cd to go in that directory. You type ls to list files and cd. Okay, so you are given this text as input, and essentially you want to construct this directory structure, a tree basically. And then the question is, problem 1, find all directories whose size is less or equal to 100k. Get the sum of their sizes. That's the problem. Okay, so you need to parse this. This is one of the more difficult problems. Your code, typically I would say 2 or 3 hours. So you have to parse this and try to build a tree out of it. So there are many ways to do it. You don't have to build a tree. You can just build all the file path. So you'll end up with a list of file path. So that's one way. But the best way is actually to build a tree. That's the ultimate solution to this problem. Because once you have a tree, that's real structure, because the directory is a tree. So you truly want to build a tree. But building a tree is not easy. So you can work around by not building a tree. So you just build a list of directory path. Then when you need to find the file size of some directory, then you just go through each one. Very inefficient. But you go through each file path and and have a lookup table of their file size. But this is not the optimal solution. Of course, the advent of code doesn't ask you for an optimal solution. All it asks you is to give the answer. So you can build a file path or you can build a tree. Okay. Now, I'm going to build a tree. But when you build a tree, there are two. You can build a tree directly. As you read this each line by line, as you read them, you build a tree. So that's one way to do it. another way I think is easier but less efficient is that you go through this input, then you build the file path first. So after that, you have a list of all file paths. Then you go through the file path, you build a tree out of the list of file paths. That's what we are doing. That's what I'm doing. So last time we did, so we have a list of file path. Okay. So now let's see. So now, so here's a Wolfram code. Let's start to do Wolfram code. Okay. So let's see. What is this? Okay. So let's start Wolfram language. Do I have more coffee? Yes, here is my coffee. So you start a new Wolfram language. Let's say 3. Start the Wolfram engine. Okay, and magnify it. Okay, and now you go back to coffee. So let's start to look at the code. Comments, okay? Am I doing good? Comments. Okay, so Happy New Year. Yeah, today is the last day. So we're gonna start to do this. So what is the so we describe the problem. We want to copy the problem. Let's first of all copy the problem. So today's talk show, yeah, that's preliminary. Okay, let's put this back. So here, let's start the problem. Okay. Okay, wait. So create a text. Okay, so that's the problem. Input, that's a sample input. Let me show you the code. Okay, code analysis, problem analysis of the problem. Okay, so now we need to copy the Wolfram language code. Open that Wolfram. Okay, copy that and go back here, paste it. And what else? So this is advent of code day 7. Then day 7b we didn't finish. Then we continue with day 7b. Okay, actually we need to copy this. Okay, so what's the difference? Okay, so yeah, so copy that, put here. Okay, so close that. So we want to see, so if we show it in browser, so we have 2 code here, 1 and 2. I want to see what's the difference. Okay, so the map function expression path. Okay, let's start to code them. Let's go to the first one and see. Okay, so here is the input. So we split the input, okay? So the input is that X input, we split into lines, process each line at a time, build a list of file path first, then turn the path into a tree. That's an algorithm outline. Each element is again a list of the file names. So yeah, so the path, our path is not a string, but rather it's a list of the names in file name. That way it's easier to manipulate. Okay, so let's so then we have path, then this is X line parts list. So what is this? Yeah, so that's the input lines, you know. So we have the list. So this is a list of list. This is a list. Each element is a line, and that line is again represented as a list. So for example, $CD is a list of 3 elements. Okay, so this is a line parts list. Okay, then here's a list of directory names. Current, is it used anywhere? Yes. Size lookup table. So we're gonna build a table, lookup table, which is a Python dictionary of key value pairs. The key is the file path in list form. The value is the size of that file. Okay. Then directory tree is our tree. Again, it's a dictionary. It's a nested dictionary. Okay. And here's a code. So this code, it will be incomprehensible to you guys, but but I understand it. Yeah. So after this, we would have file path built. Okay. So the file path will be built. Yeah. So yeah. Let's see. Map a function to file path. Okay, so if we just run that, let's see what we get. Okay, so here is the Wolfram code. Run it, go down, then type xpath, run it. So you can see each one is a directory. Let's show them in column form. So each one is a list, and it represents a full path. Okay, so we have built the path. Okay. Now, our problem is to go through this list of file paths and turn them into a tree. Okay, and the tree is going to be a nested dictionary. That is this part. So let's see. Let's build a tree, nested dictionary by going through xpath. Okay, that's what we need to do. We stuck on this last time for an hour. So what we need is to write this function. You know, after the map, we'll have the tree. Okay. Okay. And okay, so that's one thing cleared. Okay, now we understand this. Now go back. Now let's see what is this input. How is this one different from previous? let's try. Select all, paste, run it. Same thing. Okay, so the same thing. Okay, so yep. Let's see, let's clean them up. So go back and let's see, let's pop it out. This is the first one, this is the second one. So let's see what's the difference. 200 lines, 190 lines. Okay, 154. Okay, looks like the same to me. Yep. Yep, so we don't need this part. Okay, so here's our code. Now let's work on this code. Okay, now we need to write this function. Now this is the path. So okay, let's write this function. We got a list of paths. For each one, given a path such as that, you go through. So you essentially you want to do this, okay, where the key is each element of the name. Okay, let me just think about this. So again, we can use nest. I thought about this last time, so I think I kind of know what to do. So we want to nest a function. We want to use fold, okay? We want to use fold. Once it has a result, so fold result. So let me write a simpler version so we can see what exactly is the problem. Okay, so other people can understand. We want to show a independent, I mean a standalone situation of what are we doing, which is also helpful to for us. Okay. Now we want to know, are each of these a string or not? So let's take the last item and let's show input form. Okay, so yeah, so each element is a string. Great. So the string will be used as the key of the dictionary. Okay. So this will be, for example, A, B, C. Okay. So given this input, a list A, B, C, you want to build a dictionary such that you essentially want to build something like that. Okay, a nested dictionary. So the first one is with key A, the value is again a dictionary. Then you take the key B, the value is again a dictionary. A dictionary is like a container, like a folder. Then you take key C, the value is again a dictionary. Okay, so you want to take this input okay, so let's try. Given that input, you want a structure that is like this. How do you, let's write this structure. Okay, let me show you. So there is a key A. Okay, then the value of key A is again association. Okay, and the value of this association, I mean and in this association you have a key B, and whose value is again an association. And in this association, which is a dictionary, in Wolfram language, you have a key C, and this key C, the value of key C will be a file size or just null or just 1. Let's just say 1. Later on, we will have to make it a file size. So the last item, is it always a file or directory? So in some case it's a file, in some case it's a directory. Yeah, we don't know. I mean, we do know because we have built this size lookup table. For example, let's have a look, which is a dictionary that where the key is a list representing the full path, and the value is a file size. So given a path, if it exists as a key in the size lookup table, then that path is a file. Okay, so that's how you tell. Size lookup table we built before. Okay, so now the problem is that problem, turn this into this thing. Okay, and here's how we're gonna do it. Okay, last time we stuck on this for an hour. Okay, so essentially we want the function to do something like that. Okay, the function will take a value map. Okay, map, it takes subsequent value, and okay, so how do we do it? anyone here, those people who requested here, are you guys still watching? I need your input. I need your encouragement when I'm stuck. I mean, this is the actual starting to code it. This is the problem. Yeah, I know how to code it, but I have to, just think about it for 5 minutes. No talking, no moving. That's the thing. That's the problem. So you want a function. So the function takes a list. The function takes a list of things. Each time it wants to set an association, already a given name. We have a name, the tree. Each time it sets that and set it to a association. So each time it I think, okay, let's see what is our tree. Does it already exist? I mean, it does. It's an empty association. Yeah, this is a shortcut for the association. Okay, and there's nothing inside, so it's just like almost like this. Hello, I'm watching. Great, Sam. Okay, so each time you want to associate to. Okay, so let's look up the documentation for associate to. Okay, so you do that, you press that key. I'm using Xawufan mod, which is open source on my GitHub. Okay, you can just find it here. Xawufan mod. It allows you to code Wufan language in Emacs. So you can. It's on GitHub. You can go grab it. Sponsored by Wufan Research. So back to, so this is association. So we want to look up the documentation for associate to. So you give a value. So this allows you to, so you don't have to do a sign yourself. You can just, so the tree, you want to modify this association. So you say the tree, so this allows you to change or add a key value pair. So this associate to function allows you to add or change a key value pair, right? Yeah, so is that what we want to use? Yes, because we need to do this. So okay, so you call this, you want to assign or modify the tree association. Then here is the key. Okay, so you need a new key value pair. The value should be, what should the value be? We need to pick some symbol that's not used. Can we use none? Okay, none is a built-in symbol. Let's see, what does it? It's used for options. That's not what we want. Okay, so let's see. We want some. Should we use null? No, null, it represents. Null is like nil in Lisp. Absence of an expression or result. No, we don't want to use null. We want to just use some symbol. Let's see. Anything that's unique. We can use those are not suitable. So we can use 1, which is no good. We can use 0. Okay, let's say 0. So each time you encounter one of these ABC, you do that. Okay, where the key is x, as a function. So okay, so looks like that so far. So far so good. Let's clean this so it's easier to see. So we have a function of one variable. So each time you map to the input, you get a thing. So you do that. Is that all? Maybe that's all. Then let's see. Let's go through the steps. So the first time you do that, the second time the x is something else, right? The second time you want this. Yeah, okay, so this is not all. So the second time you want that. So you want the function to apply to this one of these input, and you want it to return you want it to return you want it to, so when you take the first input, you want it to return a function that can function. You want it to return what? So, well, not necessarily. You can, so if you have one thing, you do that. Then when you have the next thing, you want, so if this is the first thing, when you have the next thing, you want that where the x is the input. Wait, no. Associate to, no. Yeah, actually this is what you want. Let's think about this. The first step. Then you want that. Then the next step is what? Something like that. Oh. Let's see. Yeah, something like that. So you want to make this a function So that's one way to do it. I mean, if you do this way, you are using associate to. So in fact, this is incorrect because you are associate to is basically assign association to the tree. So here you are modifying the tree, and what does it return? So you need to know what does associate to return. Okay, do we have it? Associate to has attribute hold first. Effectively modifies the value of A in place. Yes, but what does it return? You see, typically this modify, value in place, those are procedural programming thing. So when you do associate to, this is equivalent to this is equivalent to something like that. Okay. Yeah. But when you do this, you see what does it return. So it certainly does not. So this will not work. It does not return a variable. You see, when you use associate to, the first element must be a variable. So in this case, this value is not a variable. It doesn't say, the Wolfram documentation doesn't say what it returned. Okay, so I'm pretty sure it won't work. Can this work? Now, can this work by itself? Can you actually, let's say, XX equals to that, okay? Let's try it. Nested association, nested dictionary. So, so if you want the first element, I mean, let's say you want a key by A, okay, A must be a string. You see? So now if you get the key of A, then that's key B, you got that. So you see, this can work. Correct. So you can simply do this. Okay? So now, so one of the question is, do we use a map or do we use some kind of nest? Okay, let's see what is this. So you see, if we are given that input, one way to do this is we construct this input, then we just evaluate this expression. That can be easily done. Yeah, maybe we should just do that. This can be easily done by a pattern matching. So basically, given a list, we use pattern matching, then turn the list into this expression, and it will evaluate, or we can just evaluate explicitly. So yeah, so this shows that you can evaluate them in one shot, then you have the structure. Okay, but that's for one thing. That's for one of the full path. So if you have another full path, let's see if this works. let's say you have now, for example, this one correspond to that. But now let's say if you have, the first one is always the same, let's say, but B2, let's say C2, okay, something like that. Can you do that and still maintain the integrity of that? Okay, so A, B2, C2. So let's evaluate that. Oh yeah, then we need to assign the tree. Okay, so wait. So let's copy the tree. Can you actually assign like that? If you do that, no, you cannot. Wait. Obviously you cannot run both of these, because if you do, the tree is gonna be rewritten. Once you execute this line, it doesn't know anything about that. So you cannot do this. So you need a God. You need to. So do you guys see what I'm doing? Do you guys see? Yeah, we cannot do that. Okay, so we need some other way to accumulate. So maybe back to use associate 2. Or actually, this is the best way. Why can't we just use this? Is there a reason? Okay, let's try that. Let's try clear XX. Okay, now let's just say, let's do that. Integer in that is protected. Okay, but it will work if you set XX to association. Okay. Okay, make it empty. Okay, now it's empty association. Now evaluate that. Oh. Tag missing in missing key absent ABC. Oh, okay. So that means you cannot create a key before you have association. So you have to run this first, equals to empty association, then you can, you have to do it each one. Okay, you cannot. This is just like when you have a directory path of multiple directories in the path that doesn't exist. In many programming languages, you cannot just create it one shot. You have to create the parent directory first, then create the directory of that children, then eventually you have a list of directories nested. But in Emacs Lisp, you can create them in one shot. Emacs will automatically do it for you behind it. So anyway, so we back to this. So in order to, you cannot do this one shot. In order to do this, you have to build an association for that key first. Then, okay. So that is also understood. And you cannot do this assignment because the latter overrides the previous. But you can do this though. You can do this by building each one, okay? So again, back to this problem. We have a list of paths, and this is just one single path. turn this single path to that, we can do, yeah, so we can do that. This will run, but not this, okay? Map for each one, so this will run. So given a path, so yep. So use a pattern matching that turns this expression into that. Then you need to assign it to the tree somehow, because you need to accumulate them. So use a pattern matching to turn this path into that. Then you need to attach it to the tree variable. So then you can say maybe grant root. It's just says something like this, okay? So do that first. Let's say xx equals 2. No, you cannot do this neither, because then the next line you're gonna run again, you'll just override it. You just override it. God, it really I hate this. It really is best if I just do it offline. Then where are you guys? Those people who wanted to watch, say something. Four people. Okay, I'm going to, I want to solve this, okay? Yeah, and we can do this, okay? So now, fold. We should use fold, really, or reduce, also known as reduce. So if you use fold, every time it returns, fold the function. So let's see, if we're gonna use fold, then we need a function that takes two things, okay? And each time the b is gonna be an element from there, and the a will be returns a result. Takes element, returns the result, and apply again, takes a new element. So the result, so we're gonna, when you apply fold, you are going to have last result here. And then you take a new element. Okay, so for example, let me show you. Okay, fold. Okay, F. Okay, we can show this so that let's see D. Okay, so we can see that. Okay, now the question is, we can do that. So each time it returns the result as first argument. So you want to write a function such that you want to, again, we want that, so new to this channel, is that a coding challenge? Yes. So this is, so we are doing the advent of code. Day 7, day 7. Anyway, so we stuck on this. I need to think about this. You right now, this is a problem, okay? In Wolfram language, we need to turn a list of paths into a nested dictionary. Okay, so I want to focus on solving the problem. So when you return, so f takes 2 arguments, and the first argument should be, so we are trying to make that into this. We are trying to create a function that does that. What about our pattern matching function? So many ways. We need to focus on one. God, cannot jump around. So the result will be association, something like that. So right now I'm thinking of 2 ways. One is by pattern matching, where you turn a list into that, And for example, this leads into that. But the problem with pattern matching, yes, you can do that. But the problem is that it does not accumulate. Like once you assign to the tree, then it overrides the tree. So it would be and the syntax of those is actually just this. Okay, this is much simpler to understand. Okay, so you can use a pattern matching to turn that into that. Okay, yeah, you can do that. Provided that X, the tree is already a, yeah, you can do that. So use a pattern matching. So solution is, let me say solution. Solution, use a pattern matching to turn into okay, or okay, and yeah, we can do that. Then if we do that, then that's solved. Why do we need to do this? I think we got it solved. Okay, forget about using fold. So let's try this pattern matching solution. So a pattern matching of that thing okay, let me show you guys. Okay, you can, that syntax slash dot means replace repeated. Okay, so here you want to say X whatever followed by X low line. Okay, that means first element, then one or more element. Okay, so you match this pattern. When you see a list, you break it into two parts, first element, then rest element. Then you want to replace by that. Okay, the first part is X, this, and this is the tree. Okay, replace it by that X equals to an empty association. Okay, repeat that. Okay, and this y underscore, they mean one or more times. Yeah, I think, or zero or more. Let's see. So we are doing pattern matching in Wolfram language. So let's go to patterns. Pattern matching syntax. Okay, so we here two low line means any sequence of one or more expression, one or more. Okay, so No, this is incorrect, because this way you just add everything to the root. So we looks like we still need the nest. You know, it can be done. It's just that we have to think about this. Sequence of expressions. Okay, any sequence of 0 or more expressions. Now, if you do this, it's going just to add everything to the root. No, you don't want that. So can you use map then? Map. Yes, a function. You don't know how many. Better to use fold. Fold that. Okay, then when you return, fold, when you return a thing, fuck. Okay, I think I'm gonna go for a break. So okay, a break, 5 minutes, and I'll be back. Okay, break, 5 minutes. Okay, something like that. I'm back. Okay, so we need to write a function that the function returns we need to write a function such that the function takes two arguments, f1 and f and second argument, and we need to actually apply this function to the first argument. So we want a function like that. Okay, let me show you what that means. We want the function okay. Let's say A and B arguments, okay? And we want it such that, hello Greg, we want the function to be such that A applied to B, okay? This is a function we want. The function takes two arguments, A and B, and the function body is apply A to B. Okay, so this is a function, and when we call this function, let's say to a list of values 1, 2, 3. Let's see what it returns. Okay. Yeah, that's what we want. Okay, so this is closer to what we want. Again, the problem is turn this into that. Okay, into that. So this fold function is what we want. Okay, and so given a list of path like that, we can turn that into, okay, so but this function needs to be association. Okay, it needs to be something like that. So the first argument needs to be the tree. Yeah, so fold, you can give an extra argument which will be used as the first of the first. So this part will be the tree. Okay, so for example, let's try that. Yeah, it says missing absent. So that's right, because each step we need to add it to the association. So let's modify this. So at each step, this function needs to actually add association. So argument A so what is the tree now? You see, the tree is an empty association, a dictionary. Okay, so the tree is so this function takes two arguments. The body will be take the first argument, which is the tree, which is association, then add a key. That's right, add a key B. And this key B will have a value of empty association. That's right. So, okay. So we are going to call this fold function. Okay, fold function. Let me show you how it works. What does it do? So this fold function takes three arguments. Fold, by the way, is just like reduce in Python or other languages. You it takes several arguments. The first argument is a function. The function takes 2 arguments. Then it'll just nest. Each time it got the result, it will feed the result as the first argument to the function, and the second argument will come from the list. Okay, 1, 2, 3. So you can do this. Okay, so we got that. In part missing is not a symbol. Yeah, okay, I can understand. So let's try this ABC key. Because integers, integer can also be a key. So why is so in the part assignment is not a symbol? Let's try this. Okay, let's try this, see what happens. Okay, empty, that's error. What is the tree? The tree is still empty association. So why is it wrong? So in order to see what is wrong, we can use a fold list. So it will show each step as a result. Okay, yeah, we got that because because it's trying to assign a key where the key doesn't exist, something like that. So let's not say the tree. Okay, let's remove this part and see what we get. Tag string in A equals to B is protected. Oh shit. It needs to be association. Why is it not working? So this, if we do that, this will mean, so if we run this code, what it means, the first step is that it will, here's the body of the function, so it will feed. Now instead of AB, let's use XY. So it's perhaps more clear. Okay, so the first step, what will happen is that it will take A. Let's ignore the tree for now. Okay, ignore the tree. So you'll take this list, then do reduce. So the first step, what happens is you'll get a A there. Okay, then you'll get B here. Yeah, that's the way. That's what we want. So it seems to work, but it doesn't. Why is it? It should work, not so far logically. The tree. So let's just try that. First of all, make sure what is the tree. The tree is still a empty association. Okay, so now we do that. It should work. Oh, okay. I think I know why it's not working, because at each step you you return a thing, which is the thing that returned is, you see, the thing that returned at each step is this assignment. And what is the result when you do this assignment? You see, it needs to be a symbol, or it needs to be it needs to be association. So when you do this assignment, it does not return this association, the key value pair. I mean, it doesn't return this empty association. So you need to return the association. Okay, we can do that. So you needed to return the association, assign it. Okay, so what you can do is you put a semicolon and you will say return that. Okay, I think that will work. This part, semicolon, is a shortcut for like the Lisp's PROGN. It groups a bunch of expressions into one unit, then returns the last expression. So it returns this. So at each step we create a new key, then we return that association. Okay, yeah. So now we try this. Please make it work. Fuck. Can we actually do? I mean, we can do this, right? I mean, let's do this step by step. You see, that works. That works. And now what is the tree? The tree is association with one single key. That's correct. Now, what if we do the tree A? We get a empty association. That's correct. Now, you can say yeah, we almost got it to work, but there's some logic somewhere. So can we do this now? Can we say now we add a new key B equals to association, an empty one. You see, that also works. The value returned is association. Okay, now we can evaluate that. That's an empty association. That's correct. And now we can, let's try the tree. It's going to be nested. Key A is association, then of that association, key B is an empty association. You see, nested association. That's what we want. So this will mean, A and B is the path, component of the path. And this means directory A contains directory B, and directory B is an empty directory. So all this so far works. The problem is somehow trying to get into fold now. Yeah, you have to create a directory. I mean, you have to create a key dictionary before the next one. You cannot just do this one shot. So, that's what we've been working on, trying to figure out. So, again, the problem is here, okay, in Wolfram language. So So we use fold. Okay, so this code is essentially should be correct. XY equals to association, and return that. Yeah, so why is this not working? So let's try our code again. So first of all, let's clear the tree now. Okay, and now let's run this code. This code should start with the tree and return this value. I don't understand. Key absent A. So this means it cannot find the key A. Why cannot it find the key A? Let's try again. The tree A. So let's do it again. So the first step is the tree A feed into the function xy. So you got the tree A equals to empty association. That's right. So why is the what show stack trace? Yeah, fuck. Now let's reduce this by, let's just say not so much. Missing key A, you see, that is a problem. Missing key A, but what? Why are you missing key A? Because this will mean the tree I don't know. So now let's stop using fold. Let's simply call this function and give it a argument, two arguments. The first one is the tree, of course. The second one is A. Okay, let's run that. You see, it's got a problem. So it says association in part assignment is not a symbol. In part assignment, this here is not a symbol or something. Okay, let's try a different syntax. Let's not use this. So instead we say we say that association x and y So what I'm trying to do here is that we are trying to find a alternative syntax for this, and that alternative syntax will be, let's try it. So you say it's assignment, okay? So association. Oh, I think maybe I understand. Wait, no. Very annoying. Association. Associate to. We don't want to use associate to. We want association, append to, prepend to. No. What the fuck? Associate to. Let's see association. Magnify. Okay, association. So you can assign it like that, where associate is a symbol whose value is an association. So when you do that, that part must be a symbol. That is why that is why we have the error. This X is not always a symbol, because in our case that X is actually something like that. That's right. So when you use this syntax, when you use this syntax to assign a new key or change the value of a key of association, on the left hand side it must start with some symbol. Yeah, but we do have symbol. The symbol is the tree. Once you do this, the X becomes the tree. So, and we have shown here, it evaluates to that. It's the tree. The tree is a symbol. So, this line, why does this line does not work? The tree is a empty association, right? So we have a function here, takes two arguments, x and y, and the body of the function is this. So first of all, it set x, y equals to an empty association, then it returns the x bracket y. Oh, the return value is incorrect. That's right. You see, the return value, that x bracket y, is just an empty association. That's right. So when you have an empty association, so the tree, this part becomes empty association. Then you add that, doesn't make sense. That's why you see empty association in parts assignment is not a symbol. That we found the problem. So we don't want to, so we want the function to return this thing, but not evaluate it. We don't want it to be, because if you evaluate that, the value is just empty association. You want to return the how do you say this, kind of the syntax of that thing, then evaluate it. Yeah, so we can do that. So we do that by hold, okay? This is getting very advanced Wufan programming language. Okay, we're gonna do this hold. Hold means don't evaluate it. Okay, then you can say release hold. Okay, to evaluate it. This is like Lisp macro, very advanced, far more beyond Lisp macro. Yeah, so you can, actually take some time to work it out. So what you want to do is you say you want to return hold, okay? Hold this entire thing. Okay, hold this expression. You want to return that. Then when the function call happens, you want to say release hold here. Okay, so let's cut that. Actually, let's say release hold. Okay, so you want to say here. Okay, then put this xy inside. You see, this is about symbolic term rewriting. This is term rewriting at work. Or you can think of it as Lisp macro. Everything is symbols. So again, this function is applied two arguments here, the tree and the string A. The tree, let me explain. The tree is an empty association. Let's just make sure. Assign it, the tree is an empty association. So when the function takes two arguments, x, y, the first thing it does is release it, so you got this xy form. Then assign it to association, which is empty, assign it to an empty association. Then return a held version of that, just that symbol, xy. So when the function is called again, it'll release that hold, okay? That is what we want to do. I think I'm pretty sure. Good, but probably could be wrong again. Okay, so now this release hold, okay, here. Okay, and here the last part is gonna be hold. Okay, so this is our function and apply it. Let's do it. It's going to work. Fuck. Yeah, fuck. So, okay, it's not working, but let's try this one time. Release hold, in release hold missing key. Why is it the fuck? Okay, so let's see. Let's say M, okay? What does it actually do? You got So you want it to return a symbol. God, this is terrible. This shouldn't be this hard. Something, we simply want to turn that into that. Can we use this form instead? Let's just use eval. Let's use pattern matching to transform it, then eval. Yeah, but you have a nested situation here. So when you want to turn a flat list into a nested situation, you have to use nest or fold or the repeated pattern matching / dot. One of these ways. Yes, you have to use one of these ways to turn a flat list. This represents a path, okay? So this is not actually XX input. This is one path. Turn this file path represented as a list into this, okay? And so a flat list into a nested form, there are several ways to do that. One way is to use a repeated pattern matching replacement. Okay, this thing is called replace repeated. You see there. Okay, so this is the you see / dot. That's a shortcut, syntax shortcut. So you can use that to generate a nested situation from a flat list, or you can use fold, which is what we are trying to do, but so far failed. Or you can use nest. Okay, the difference between nest and fold is that fold takes two arguments. You can take a list of things. Each time you take a new item from that list. While if you use nest, again, let me show you nest. If you use nest, it doesn't take extra thing. It just nests the function, 5 times. So it doesn't take a new input. So in our case, we need to take a new input each time from the list ABC. So therefore, we can use, the replace repeated, or we can use fold. It's possible to use nest too, but then you have to embed this list into the function. You have to embed the list into the function. But let's use fold. Okay, fold is more, like that, suitable. It returns that. Okay, fold. It creates nesting from a flat list, right? Makes sense. And now, but okay, and basically we just want to get this. You see, this is a solution. We want to turn that into that, and we want to do this multiple times for each different, path. So why is it so difficult? So we want to turn a flat list into that. The problem is there are two problems. One problem is how do you get these two, if we want to do this, turn that into that, that's what we are doing with the fold. So why is our fold release hold doesn't work? Let me show you how the hold things work. Hold 1 plus 2, okay? It doesn't change nothing, but you can now say release hold, okay? And you can do that, then it becomes 3. So hold simply kept this expression as is. That's why we want to keep that as is. Okay, maybe we move this part, association, inside the release hold. Yeah, maybe. Okay? Please. Fuck. Why is it so hard? What the fuck is it? Okay, maybe there's release hold all. Fuck. Yeah, God. Every time you do this, whenever there's an issue with evaluation, it's very complex. Okay, removes only one layer of hold. It does not remove inner occurrences in nested hold. That's the thing. So you want non-standard evaluation. So I thought there's a release all. Okay, evaluation control. Evaluate, immediate evaluate function argument. Release hold all complete. Is there a release all? I think there's a release all. No. Well, okay, what is release? Release is system related. Oh yeah, it's obsolete. Okay, so hold form defer, but evaluate if given a Wolfram language input. Okay, hold, evaluate, unevaluate, release hold complete, hold pattern. Let's see hold. Yeah, these are fairly complicated. Map hold, apply a list to what? Hold complete, and very complicated. Attribute hold all. Sequence hold. Sequence object appearing in the argument of function. Okay. Okay, I got something. Wait, I don't know what is going on. Okay, hold, release, hold, yeah. Function, release, hold. Why does this not work? What about release? Let's try hold form. Okay. No, it still doesn't work. Let's see what is the tree. The tree is empty. Yeah. Something is really wrong here. I don't understand. Let's try evaluate. Causes expression to be evaluated even if it appears as argument of function whose attributes specified should be held unevaluated. Okay. So evaluate inside hold. Oh Jesus, so complicated. Hold all is an attribute. No, attribute is not what we want. Attribute, so Wolfram language is just like Lisp, where a Lisp symbol has many properties. You can attach properties to Lisp symbol. Similarly, in Wolfram language, symbols can have attributes. They call it attribute instead of properties. So you can give a function or any symbol several attributes. So when a symbol has the attribute hold all, then when it's evaluated as a function, it will not evaluate its arguments. So that's what this hold all is for. Okay, so this is useful when you want to implement your own if statement or while loop. You don't want to evaluate the argument right away. You want to check if it's true or not, then evaluate this part or that part. So that's when you want to attach this hold first, hold rest, attribute. You want to attach this attribute to a symbol. So that's what this hold first, hold rest is also an attribute, and hold all, that's also an attribute. Okay, that's what these hold are for. Okay. Now, however, what we want to do is, what about hold all complete? That's also an attribute. Okay, so you can attach it to a symbol. Just like Lisp's symbols properties. Okay, so those are attributes: hold all complete, hold first, hold all, hold first, hold rest, hold all complete. Those are attributes you attach to symbols. Now, hold is not an attribute. Hold is just like a function. It just attach some expression. Then it will not evaluate anything in the expression. Okay, well, the way it works, because the hold has the attribute hold all. Okay, so it's kind of confusing. Okay, so that's why we want to hold this part, x bracket y, because if you don't hold it, then it just returns an empty association. So your function returns an empty association. So, and each time it takes two arguments, it doesn't work, because empty association, it doesn't attach to the tree. Let's see where we are. Yeah, so here is the way we had it. This becomes empty association. And so when this evaluates, this x is an empty association. But why support assignment is not a symbol? Yeah, so this x becomes an empty association, and that y becomes this a, but this form must begin with a symbol. We want it to begin with the tree, okay, but it's not, because this x bracket y. Wait, why does this not work? Function, this should be evaluate to this, okay? This equals to association. This should evaluate to, yeah, so we got a problem. I don't know what the problem is. There's something we don't understand. This should return, that, okay? This should return this. Oh, exactly. It did. Wait, no, but we did assign it to an empty association. What? So right now it's missing a, yeah, but we assigned it right here. Why is it missing a? Well, it's not missing because we actually just assigned the a should become the empty association. I don't know what's going on. So let's modify this. Let's use a different syntax like we talked before. So instead of that, okay, let's write this in a different syntax. Okay, let's try to, yeah, here. So instead of that, we want to say associate okay, x, okay, and right arrow. We write it this way. They are equivalent. Okay, so let's write that way. They should be equivalent. So copy this line and paste that. What? Copy delete, paste, yeah. Run it, same thing, same fucking thing. It's not a variable with a value. Don't you get the tree? Okay, okay. I think I'm gonna shut down then. 5 people failed today. This problem pretty embarrassing. So we have, the situation is that we have a list of paths. Show them in column, in one vertical column, so you can see that each one of these represents a full path, but as a list. We want to turn this into a tree structure by using a nested dictionary, like Python's dictionary, but in Wolfram language that's called association. Okay, so it's like Lisp's associative list. So the problem is to turn a list of full path like that into a nested dictionary, and we failed at that for the 3rd time basically. We worked previously 2 hours we failed. So we have been trying to work on one path at a time. So basically this represents one of these paths. We want to turn this list into this. This will work, by the way. For example, if I run this, so you got the nested association. We got the association, a dictionary. We got a key A whose value is association, and it has a key B whose value is again association. So this expression works. So for that you can. We have problem. We have problem right now turning this into that just for this one single path. That's what we've been stuck on for the past hour. Incredible. I can't believe I stuck on this problem. Fuck, this is kind of so we tried a few things to turn a flat list into a nested structure. We can use repeated replace, or we can use fold, or we can use nest, but apparently fold is more natural. However, we are running into this problem I can't figure out exactly, and the reason seems to be, let's do hold again. Let's try hold again. The reason seems to be, we got what? We got bracket problem. Yeah, okay. The reason seems to be it's returning empty. We got this evaluation situation. You see here, the error message makes it clear what's going on. The error is basically we have a empty thing there, association, that empty association. That need to be a symbol, like needs to be the tree. Okay, that part needs to be, this part, if this is the tree, it'll work. You see, this is output. This should be the tree, but somehow it's not getting it. You know why? Chen Su. Why is that? You know, maybe you know Wolfram language. Can you say quickly? I think there's a delay, like 30-second delay between I seeing your message and because I'm don't know Wolfram language, but did several tests. Okay. So what is the problem? Yeah. So we it's getting an empty list. Oh, maybe it should return, wait, because the value of that, wait. Yeah, I don't, there's something. So do you know, quickly, I'm gonna close because I think maybe I'll shut down. I need to go. This is 2 hours, no good. 1 o'clock, 1, 2, 3, almost 3 hours. Maybe because for the first time it would evaluate as association. Oh. No. Well, because we give it the tree here, you see. So, for example, if we can move this the tree and add a new argument, that's how you can give a first argument to fold. That's, for example, fold. Let's say fold a function f, the first argument, let's say a, then let's say list b, c, d. You see, the first argument will be a. So here the first argument is the tree. There's somewhere we can use print. Okay, so we can use print here to figure out what's our problem. So add a print. So what we're gonna do is we add a print statement. Debug. Okay, we want to print what the fuck is this x and y. Okay, print the argument. Okay, now let's see. So you are right. Wait, okay. Oh, the first time you need to hold the tree. I think you are right. Maybe. Hold the tree, A is protected. What? Oh, we need to use go back to release hold. Okay. Something like that. Okay, we so let's see. Let's print. Okay, so when the first time it's called, it's holding the tree. The second time it's called. So can we do release all? Okay, so we need release hold. Okay, is there a release all? Let's try it. Okay, what happens if you have release hold, then you have hold, then you have nested hold. Let's say 1 plus 2. Okay, let's evaluate that. paste it. Oh, you don't only release one time. let's just add another release hold. Let's just hack it. Fuck. Let's just add another release hold. Yeah, where it should be? Where is our what? We have too many. Here. Wait, we need to fold here. What? Too many shit. Oh, here. So let's just do here. Let's do it twice. Yeah. Where's our fold? Here. Okay. Let's release hold twice. Maybe we need the evaluation precedence. Release hold twice. Now random hacking is not gonna do any good. You need to understand it, but do it. So yeah, you are correct. I think you are correct in that. Okay, I don't know. So I think that's it for today. We failed another 3 hours. Okay, bye guys. I'm gonna walk offline. I need a break. Yeah. Bye guys. Happy New Year. End of the year. Bye.